Let's see this in the lab. We're going to use Packet Tracer. As you can see here, we have two offices here, Office 1 and Office 2. Office 1 has these 4 PCs, 3 engineering PCs, 1, 2, and 3, and 1 sales PC. On the other side, we have Office 2, which has 5 PCs, 3 sales PCs, 1, 2, 3, and 2 engineering PCs, engineering PC 4, engineering PC 5. And in the middle, we have a layer 3 switch that's connecting the two offices. And right above it, we have a router. Let's see how to configure these in the Packet Tracer. All these devices, the router and these 3 switches, they're all in the factory default state. Let's verify that there is no VLAN set up on these switches. Let's go on switch 1. Let's go on switch 1. Open up the command line interface. Enable. Let's set the host name to switch 1. Config T. Host name switch SW1. See, now changes the switch name to switch 1. Let's do the same on switch 2. Enable config T host name switch 2 SW2. There we go. Now on switch 3, config T host name SW3. Now let's verify there are no VLANs set up on these 3 switches. On switch 3, we type show VLAN brief. We have to drop back 1 level. Exit. Show VLAN brief. As you can see, there are no VLAN set up. There's only VLAN 1 and all these factory default settings. Let's check on switch 2. Switch 2. Let's drop back 1 level. Show VLAN brief. Again, as you can see, there are no VLAN set up here either on switch 2. Now switch 1. Show VLAN brief. There are no VLANs set up here either, as you can see. No VLANs set up. There's nothing there. Now, let's view the default switch port status on the link from switch 1 to switch 2. So we open switch 1 and show interface gigabit 0/1 switch port. Let me maximize this so you can see clearly. Okay. Let's scroll through. As you can see, the administrative mode is set to dynamic. That's the default factory setting. The operational mode is set to static access, and the native mode is set to VLAN 1. Okay. Let's do the same on switch 2. Let's check switch 2's interface gigabit 0/1. show interface gigabit 0/1 switch port. It's exactly the same. Dynamic auto, static access, and the default VLAN is VLAN 1. Obviously, we want to set up, like we discussed earlier, whenever a switch is communicating with another switch, we have to set up trunks on the ports. Let's configure the links between the switches as trunks. We go on switch 1. Config T, global configuration, interface gigabit 0/1 switch mode trunk. And if you drop out of this, if you show, we dropped out of this. If you check now, if you check the interface gigabit 0/1 switch port, you're going to see that the new mode is set to trunk switch 2. We do the same. Interface, first of all, global config, interface gigabit 0/1 switch trunk. Remember when we discussed and said that ISL is an obsolete trunking protocol, a proprietary trunking protocol by Cisco. Now the old switches still have it as an option. So now you have to specify which trunking protocol you want to use. So for this instance here, we're going to clarify and say switch port trunk encapsulation Dot1Q, because that's the one we want to use. Switch mode trunk. Now the trunk is set up on both ends, on both interfaces between switch 1 and switch 2. Now we're going to configure the trunk configuration between switch 2 and switch 3 on both interfaces, gigabit 0/2 and gigabit 0/2 on the other side of the link. First of all, let's do switch 1 first. Let's start with switch 2. We go to the interface label, interface gigabit 0/2 switch trunk encapsulation Dot1Q switch mode trunk. Now it is set up on switch 2. Let's go on switch 3. Let's set up the interface gigabit 0/2 as well. Let's set up the trunk on that interface. Global config mode, interface gigabit 0/2 switch mode trunk. Now we have the trunk set up between the three routers. Let's check that on switch 3. Let's see whether the trunk is set up properly. So the command for that is show interface gigabit 0/2 switch port. There is a typo. Switch port was misspelled. Okay, now as you can see, the operational mode is set to trunk and the operational trunk encapsulation is Dot1Q. Perfect. Let me exit out of here. Now let's configure switch 1 as a VTP server, and switch 2 as the transparent switch, and then switch 3 as the client switch. As you can see, first of all, before we do that, you can see that show VLAN brief. You can see we have no VLANs set up on this switch 3. What we're going to do now, using switch 1 as a server, we're going to configure the VLANs on switch 1, and hopefully switch 3 will be able to learn and pick up those VLAN names from the VLAN from the switch 1 server. Let's configure that. Back to global config. The command for that is VTP domain, and let's call it, what's the name of this company here? Let's see, for this example right here, I called it Networking Solutions Inc. Okay, let's call this domain something like that. Networking solution. Let's name it something simple. Network Inc. Okay. Next, VTP. The next command is VTP mod server, and now we're going to configure the VLAN names. Okay. Now, let's go back to the topology. As you can see, we have the sales team and engineering team. Let's configure 2 VLAN names, and I'm going to use VLAN 10 for engineering, and the name is eng, and then I'm going to use VLAN 20 for sales. Okay, we have the VLAN set up on the switch 1, which is our server. Next, let's configure switch 2 as a transparent switch. Switch 2 should not be able to learn the VLANs we configured on switch 1. What it's going to do, it's going to facilitate the transfer. It's going to pass on whatever VLANs we have from switch 1 over to switch 3, but it's not going to update its own database. Okay, let's set up switch 2 VTP domain. We have to name it exactly like we did. Domain network Inc. and VTP mode transparent. Okay. Now we're done with this part. Let's go to switch 3. Let's configure this switch as a client switch. VTP domain network Inc. Now we do this on the global config level. Config T VTP domain network Inc. Next, VTP client, VTP mode client. Okay. Now, switch 3 is set up as a client switch. Let's see if it's learned Let's see if it has learned the VLAN that we set up on switch 1, which is the server switch. Okay, let's exit out of here. Now, show VLAN brief. There we go. Look at this, guys. We have the eng VLAN 10 and cells VLAN 20 showing up on the switch 3, the client switch. Back on switch 1, the server switch. Show VLAN brief. We have our VLANs configured. Back on switch 2, let's check the VTP settings. Show VTP status, and that's the command that you're going to use. Show VTP status. As you can see, switch 2 is set up as transparent, switch. If you do the same for switch 1, show VTP status, you can see that server 1 is set up as switch 1 is set up as server switch, and the domain is network inc that we set up on the switch server. And then switch 3 over to switch 3, show VTP status. It is set up as a client switch. Now, as we can see now, we have VLANs, the two VLANs configured across all 3 switches. If you had hundreds of switches, and all you needed was to set up one server and say transparent switch and the server switch, and then the other 98 or 90 whatever switches would learn the VLANs from the server switch automatically, and that's going to save us a lot of time. That's going to save you a lot of time. However, you have to be careful, because server switches can learn and update their table with VLAN names from its peer server switch, especially when the peer server switch has a higher revision number. So you have to be careful not to plug in any new switch that has a higher revision number, because if that switch comes in and it has no VLAN configured, it's going to update your already configured server, and you're going to take down your network. Be careful. Again, let's go back on the switch number 1. Let's check the VLAN configurations. As we can see, we have the 3 VLANs set up, and let's do the same on switch number 3. Show VLAN brief. There we go. We have the 3 VLANs learned from the server switch number 1, because we have switch 3 configured as a client switch, and switch 1 because we have switch number 3 set up as a client switch. Let's verify that. Show VTP status. Here it is. Switch number 3 is set up as a client switch on the network inc domain name. Okay. Back on switch number 2. Remember guys, switch number 2 is your transparent switch. You should not be able to learn those 3 VLANs that we set up on the server switch number 1. Okay, let's verify that. Show VLAN brief. As you can see, there's nothing set up on VLAN on the VLAN interface because the transparent switch did not learn any VLANs from the server switch. Okay, we have to manually configure these 3 VLANs on the transparent switch. Okay, let's do this. Let's go to the global config mode, VLAN 10 name eng for engineering, and VLAN 20 name sales, and then lastly we got VLAN 399, the default VLAN, the native VLAN. Okay, and the name is native. Let's go back and verify and see if the 3 VLANs are set up into switch number 2. Show VLAN brief. There we go. We have the 3 VLANs now set up on switch number 2. Okay. Next, now that we have the default native VLAN set up on all 3 switches, let's configure the trunk links so that they're able to use the VLAN 399 we just created. Okay. Back on switch 1, we're going to go to the interface level. So the global config interface gigabit 0/1. This is the interface that's facing towards switch number 2. Okay, this interface right here, gigabit. It's this interface right here, gigabit 0/1. And we're going to say switch port trunk native VLAN 399. Okay, and it's going to say that there is a native VLAN mismatch discovered. That is because we have not set up the trunk on the other side of the link over on switch number 2. Okay, let's go over to switch number 2 and let's do the same. Okay, be mindful that switch number 2 has got 2 interfaces, one gigabit 0/1 facing towards the first switch, and then gigabit 0/2 facing towards switch number 3. So we're going to have to configure both interfaces. Okay, let's do this. Let's go to the global config interface gigabit 0/1. This is the one that's facing towards switch 1. I'm going to say switch port trunk native VLAN 399. Okay, and now let's see what does the dialog say here. Okay, it says port consistency, so that's good. It is unlocking gigabit VLAN, the trunk link on that side towards switch number 1. Okay, so this is good. Port consistency is restored. Let's do the same on interface gigabit 0/2. This is the interface facing towards. This is that interface right here that's facing towards switch number 3. Okay, I'm going to say switch port trunk native VLAN 399, and let's cross over to switch 3 and do the same on that interface gigabit 0/2. Let's go to the global config, interface gigabit 0/2, switch port trunk native VLAN 399. Okay, now, and that's the message we get from the dialog. It says port consistency. Okay, the trunk links for the default, the native VLAN, is properly set up. Now let's verify whether the default VLAN 399 is properly set up, and let's verify also that the trunking between these links from switch 1 to switch 2 and from switch 2 to switch 3, let's make sure they're properly set up, and let's verify and see that the default VLAN is no longer VLAN 1, that it's been changed to VLAN 399 for security purposes. Okay, let's go back one level on switch 3. We're going to say show interface gigabit 0/2, and this is the interface that's facing towards switch number 2. Switch port. Okay, as you can see, perfect. The default native mode has been switched from the default VLAN 1 to 399. That's perfect. That's perfect. That's what we want. Okay, let's do the same on switch number 2. Show interface gigabit 0/2, switch port, and this is the interface facing towards switch 3. It's also been updated to the 399 native VLAN. Okay, lastly, let's check switch number 1. And switch number 1, we're going to do the same. Show interface gigabit 0/1, switch port. Okay, perfect. The trunking native mode has been successfully set up to 399, the native default, across our 3 switches. Back on switch 1, let's configure the switch ports to the PCs with the correct VLAN configuration. Back to the configuration level. Interface range fast Ethernet 0/1. Let's see. As you can see, we have engineering 1, engineering 2, and engineering 3, they're all using, the first one is using fast Ethernet 0/1, the second one is 0/2, the third one is 0/3. This is in sequential, it's in order. This is going to make the work easier, a little bit easier. So instead of configuring one interface by one, we're going to configure this as a range. That should save us a little bit of time. So fast Ethernet 0/1-3. So basically 1, 2, and 3. We're going to configure all three all at once. All at once. And switch mode access, switch access VLAN 10. So we're giving the three PCs in the engineering department access to the VLAN 10. Okay. We do the same for the sales PC right here. Okay. Interface fast Ethernet 0/4. Switch mode access, switch VLAN 20, which is sales. Switch access VLAN 20. Okay, and this is going to give this sales PC access to the VLAN 20. Okay, now switch 1 configuration of the switch ports access mode is done. Let's move over to the switch number 3. Let's do the same. Exit. This drops us back to the global configuration level. And we're going to do the same. Interface range. And then now on this side we see sales 1, sales 2, and sales 3 PC. They have fast Ethernet 0/1, fast Ethernet 0/2, and sales 3 has fast Ethernet 0/3. Obviously, since it's in sequential order, it's going to make this easier to configure. Like we said, fast Ethernet 0/1 all the way to 3. Switch mode access, switch access VLAN 20. And we're giving access to VLAN 20 to all these three sales PCs over in the Office 2. So 1, 2, and 3. And then we're going to do the same for the engineering PCs. And they have, we have fast Ethernet 0/5 going over to PC5, and we have 0/4 for PC4, engineering PC4. Okay. Interface range, fast Ethernet 0/4 all the way to 0/5. Switch mode access and switch access VLAN 10. Okay. Now we have the VLAN access configured on the ports to the PCs. Let's verify that PC1 has connectivity to PC4 over on the other side, okay? Let's open up the command prompt. Ping PC1, ping 10.10.10.14. Perfect, guys. Look at this. I'm getting a reply back from PC4 in Office 2. So PC1 over from Office 1 is being able to communicate with PC4, engineering PC4 over in the office, in the second office, Office 2. Okay. Let's see if sales PC1 is able to communicate with sales PC4 over here, okay? Let's see. Ping, so sales PC1, ping 10.10.20.14. Perfect. We're getting a reply back as well. So the ping is successful. So sales PC4 is able to communicate with sales PC1 across the network that we set up. Okay. Perfect. Now, obviously, as you can see, so far we have been able to ping. We've been able to ping PCs within the same VLAN. Okay. Sales PC1 to sales PC4, engineering PC1 to engineering PC4. They're all in the same VLAN. Engineering VLAN is VLAN 10, and sales VLAN is VLAN 20. Let's try to ping across a different VLAN and see what happens. Okay. For instance, let's try to ping. Let's have sales 1 PC try to ping engineering 1 PC and see what happens, okay? Sales PC1 ping 10.10.10.11. So sales PC1 over here. Let me move this so you can see. Sales PC1. Let's see if it's able to communicate with engineering PC in a different VLAN, okay? See, it's failed already. The request timed out. Okay? Obviously, it's not going to be able to ping because, like we said, VLANs segregate the LAN into separate, manageable, smaller domains, and devices, end host devices, are not going to be able to communicate if they're in different VLANs. Okay? Obviously, you want to put the right end host in the right VLAN so that this issue does not happen. Okay? If you need to have end host devices communicate with each other, but they're in different VLANs, that's where you're going to have either a router. You're going to need to have a router or a layer 3 switch to be able to send that traffic across the different VLANs. Okay. The next section, we're going to talk about the 3 ways to route the traffic between different VLANs.